All right, welcome to this exciting explainer on navigating the science lab safely and effectively. You really should think of the lab as this incredible space of magical discovery. And your tools, well, they act as the superpower extensions of a great scientist. Because whether we're measuring, observing, or heating, mastering your equipment is quite literally the very first step toward unlocking the secrets of the universe.
So here's our agenda for today. First, welcome to the lab. Then, tools for observation. Third, measuring equipment. Fourth, holding and heating safely. Fifth, testing your lab knowledge. And finally, number 6, essential lab safety rules. Section 1. Welcome to the lab, your scientific tool belt. Okay, let's dive right into this. The lab is a phenomenal place, but unlocking those massive scientific discoveries requires precision, a ton of respect for your environment, and knowing exactly how to use what's in your tool belt. I mean, you wouldn't try to build a whole house with just a spoon, right? In that exact same way, every single tool in the lab has a specific, unique purpose. Section 2. Tools for observation. So we're kicking things off with the tools that help us see the unseen. These instruments essentially extend our vision far beyond what the naked eye can catch, letting us peek right into the microscopic building blocks of life itself. And our absolute primary observation tool is, of course, the microscope. Now, when you're handling this incredible piece of tech, you've got to carry it like a prized possession. Always use 2 hands. You place one hand firmly holding the arm and the other supporting right up underneath the base. You never ever want to swing it around or touch those super delicate lenses with dirty fingers. Section 3. Mastering measuring equipment. Moving right along, let's explore how we achieve perfect accuracy. Because in science, precise measurement is absolutely everything. Even a tiny miscalculation can completely change the outcome of an experiment, so handling these tools correctly is just not negotiable. Meet your new best friend for liquids, the graduated cylinder. This is your absolute go-to instrument for measuring liquid volumes accurately. It gives you a way better, much more exact reading than a standard beaker would. But actually getting that right number requires a very specific, careful technique. So the crucial point here is you have to always place it on a completely flat, stable surface. No holding it up in the air. Then you need to literally bend down and read the measurement exactly at eye level. You're looking for the lowest point of the curve of the liquid, which is called the meniscus. Doing this prevents parallax errors and guarantees your volume is spot on every single time. Now, when it comes to measuring mass, the electronic balance is perfect. It gives us this incredibly precise digital readout. Just remember, you always have to use weighing paper or some kind of container. Never put your raw materials directly on that metal pan. Keep it clean, keep it dry, and definitely never overload this highly sensitive device, or you could permanently fry the internal sensors. This next one is a seriously cool piece of equipment, the vernier caliper. It's a specialized tool that accurately measures the outside or inside diameter, thickness, and even the depth of objects. When you're using it, be sure to slide that movable jaw gently. Never force it tightly around an object, and always check for a 0 error before you even start measuring. For checking temperatures, you're obviously going to grab your thermometer. Hold it gently and keep it perfectly upright while taking your reading. And here is a huge pro tip that every great scientist knows. Never, ever use it as a stirring rod. Seriously, it's made of fragile glass and can snap so easily, which is definitely a messy hazard you do not want to deal with. Section 4. Holding and heating safely. Let's switch gears a bit and see how this all builds into holding and heating our exciting experiments. Because once we introduce fire and high temperatures into the mix, safety and proper handling become even more critical. Beakers, along with Erlenmeyer flasks, are your absolute workhorses for holding, mixing, or heating liquids. They're great for approximate volumes, but listen closely. Before you even think about putting one on a heat source, you must always inspect it for tiny hairline cracks. Heating cracked glass can literally cause it to shatter instantly. The right way to handle these containers when they're hot is with proper thermal protection. Think tongs or heat-resistant gloves. Contrast that with touching a hot beaker with bare hands. Remember, hot glass looks exactly like cold glass. Also, heating a tightly sealed flask is a massive lab no-no because the pressure built up will just cause an explosion. For smaller, colorful, and sometimes highly reactive chemical reactions, we use test tubes. They're basically the classic symbol of a science lab, right? But remember to be gentle with them and never overfill them, especially if you plan on applying any heat to whatever substance is inside.
And speaking of heating, if you are heating that test tube, you absolutely must use a sturdy test tube holder to keep your fingers safe. This is crucial. Always point the open end of the test tube away from yourself and away from your lab partners. It's kind of like a tiny geyser. If the liquid suddenly boils over, you want it shooting at an empty wall, not your friend.
Section 5. Testing your lab knowledge. Okay, you've learned the tools, you've learned the techniques. Let's put all this fresh knowledge to the test with some real-world lab scenarios to see if you can spot the correct procedures in action.
All right, question time. How should Anna accurately measure 45 milliliters of collected rainwater? Picture this scenario. After heavy rain, Anna's group collects rainwater for a school investigation. She needs exactly 45 milliliters in her graduated cylinder. Should she hold the cylinder up in the air, place it flat and read at eye level? Tilt it? Just pour quickly and guess? Lock your answer in your head right now. Well, if you chose placing it flat and reading at eye level, you are totally correct. Just like we talked about, the cylinder has to be completely flat on the lab table, and that meniscus must be read precisely at eye level to avoid any sneaky measurement errors. Awesome job. Next question. What should Liza do before using a dusty microscope? So Liza's group is gearing up to observe some onion cells. But when she grabs her microscope, she sees a bunch of dust build up on the delicate eyepiece and the objective lenses. How should she clean it? Will she wipe it gently using clean lens paper, rub it firmly with her cotton uniform, wash it with soap and water, or just rub it with her fingers? The only super safe move here is gently wiping it with lens paper. You have to use that specific lens paper. Using your uniform or your fingers can leave oily smudges behind or cause disastrous, permanent scratches on some very expensive glass. Section 6. Essential Lab Safety Rules. To wrap up this explainer, let's pull back to the big picture and look at the foundational mindset of a highly successful, mindful scientist. Because tools are amazing, but really only when they're paired with absolute safety. Always wear your safety goggles when needed. Always check for damaged glass before starting. Never ever play around with the tools. Report accidents or spills immediately, no matter how small. Make sure to clean and dry your gear, and most importantly, always follow your teacher's instructions. These golden rules aren't just annoying restrictions. They are the exact empowering habits that ensure every single experiment is safe and successful. So, with your tool belts fully packed and your safety knowledge totally locked in, what will your very first scientific discovery actually be?